Hi, welcome to our channel of IGNOU audiobooks, Indira Gandhi National Open University, School of Interdisciplinary and Trans-Disciplinary Studies, SOITS, Master of Arts, Environmental Studies, MAEVS. First year, MEV 014 Sustainable Natural Resource Management. Block-1 Natural Resources. Unit-1 Overview of Natural Resources, 1.0 Introduction. A resource is a stock of anything valuable and can be natural or man-made. A resource that occurs in nature is called a natural resource and is not manufactured by human, but is available in nature itself. The survival of human and other living organisms depends on these resources, and these resources are regarded valuable in their natural form. These resources can either be renewable or non-renewable. The former refers to those resources that can replenish themselves over the years and include living resources like forests or non-living, for instance, wind, water, solar energy. Non-renewable resources are those resources that can no longer be harnessed once the accessible store is drained. For instance, mineral resources and fossil fuels are non-renewable even though they can restore themselves, but the renewal process requires million years to complete. Renewable resources, for example, wind and water, have been used in the past and are the main energy sources, having the benefit of producing lower carbon emissions. With the developmental activities, human has ruthlessly harnessed the resources, which has posed threats to survival to human civilization itself. In order to conserve these resources for future generations, it is important that these resources are used judiciously. 1.1 Objectives. After studying this unit, you will be able to understand the meaning and concept of natural resources, identify the types of natural resources, describe the valuation and uses of natural resources, assess the availability of natural resources, factors affecting the availability of natural resources, and understand the distribution of natural resources. 1.2 Definition and concept of natural resources. Anything on the earth which is of any value to humankind is called a resource. A resource produced in nature and utilized by human is known as natural resource. It includes air, water, soil, mineral, flora and fauna, and energy goods. For example, coal, gas, that serve human requirements. The resources present in nature are thus nothing more than neutral material, till human identify their presence and importance and develop ways to capitalize them. Natural resources are constituents of ecological setting, and being unique, these are used by people for supporting life and livelihood. These also include industrial raw materials and renewable resources such as timber and fisheries, other than common property resources. Some resources, such as minerals or oil, exist as limited stocks and are non-renewable within a specific time frame. Others, such as timber or solar energy, are renewable, and possibly the flow of services from these resources can be gained for an unlimited period. For example, solar radiation, winds and waves. Renewable resources, if mishandled, ultimately exhaust. In addition to the usual terminology used with regard to natural resources, there are stock resources, which take millions of years for formation. These can further be recoverable and recyclable stocks, while the flow resources are the resources which can be naturally renewed in a short time period. Besides this, there are currently exploitable resources, which are the supplies of material or energy that can be usable in political, economic and technical terms. Thus, natural resources, economically referred to as the land, are raw materials that occur naturally within a particular setting, relatively undisturbed by mankind, in a natural form. Natural resources are derived from the environment and are essential for survival of mankind. On the basis of origin, resources may be divided as biotic and abiotic. Biotic resources are obtained from the biosphere and include forests and their products, fauna, and minerals formed from decayed organic matter. Abiotic resources comprise of non-living things such as land, water, air, and minerals such as gold, iron, copper, silver, etc. Natural resources constitute the most important components for human survival and development. One cannot even think of development in the absence of natural resources. Ever since human was born on earth, he has been dependent on natural resources. The natural resources are being exploited to provide material for forest-based industries, development activities including hydropower development and to meet demands of local population for fuel, fodder and timber. 1.3 Classification of natural resources. Natural resources vary greatly with location, climate, soil, quantity and quality. For instance, a specific forest type may occur only in some nations. Likewise, the geographical area covered by the forest and wood quality may differ extensively across different countries. A suitable categorization of resources is based on their exhaustibility and renewability. Basically, based on their availability, the resources can be categorized as inexhaustible or exhaustible. 1.3.1 Inexhaustible resources. Inexhaustible resources are available on the earth in infinite amount. While some inexhaustible resources remain almost unchanged by human impact, many others may show some changes in their quality, yet their quantity may remain unaffected. 1.3.2 Exhaustible resources. A number of natural resources are exhaustible, they have finite stock on the earth and can drain if used unsystematically. Generally, the exhaustible resources can be renewable or non-renewable. Renewable resources. Most of the biotic resources are renewable, however. If the utilization of these resources exceed their rate of renewal, not only their quality gets affected, but these may completely exhaust. These include 1. Forests, which produce timber and other plant products. 2. Rangelands, which sustain grazing animals. 3. Wildlife, which sustains the food chain. 4. Farming systems, which produce food and fiber. 5. Marine and freshwater systems, which produce various foods. 6. Soil and water, which sustain life. Non-renewable resources. Some biotic resources are non-renewable, i.e. they cannot be recovered or recreated once they are exhausted. Biological species, which have evolved in nature, are considered non-renewable. Once a biological species becomes extinct from the earth, it cannot be reinvented by human. Many abiotic resources, for instance, fossil fuels, coal, petroleum and gas, and metals, are non-renewable, because once taken out, these cannot be renewed. 1.4 Value and uses of natural resources. Amongst the Earth's natural resources, the following contribute considerably to human welfare. I. Land. E. Water. E. Forests. IV. Minerals. V. Food and V. Energy. 1.4.1 Land resources. Land is one of the most important resources, which helps in sustaining life. The nature or Prakriti, as known in Indian context, is believed to be the supreme mother of entire creation. Even today, Earth is regarded as Bhudevi or Dharti Mata, Sanskrit names for Mother Earth. Land is the most important natural resource on which entire human activity is based. It is used for agriculture, construction of houses, roads and railway tracks, establishing industries, grazing animal, mining activities, etc. In brief, virtually all human activities linked with food, shelter and clothing occurs on land. Land consists of soil, which is a combination of organic and inorganic matter. The organic component consists of dead and decayed parts of animal and plants, known as humus. The inorganic component is made up of rock particles and minerals. The services provided by land and soil are production of biomass through farming and forestry, conservation of groundwater and continuation of food chain, biodiversity conservation by buffering activities, preservation of genetic diversity, provision of suitable habitat for floral and faunal diversity, provision of infrastructural development, such as sheltering, industrial, manufacturing, transportation, dumping, sports, recreation and others, provision of raw materials, gravel, sand, clay and other minerals, and safeguarding geocultural heritage by concealing and conserving archaeological remains. 1/4 area of Earth is the land, which is mainly covered with farming landscapes, natural forests, grasslands, wetlands, and man-made urban and rural settlements. Among all land resources, soil is the most important and consists of inorganic constituents, organic matter, air, water, and a variety of organisms. It takes years for the development of soil horizons. Natural phenomenon and human activities often create problems like soil erosion and reduction of fertility. Soil erosion is basically the removal of topsoil from the land by natural factors like water and air. Human activities like deforestation accelerate soil erosion and results in loss of soil fertility by transportation of organic matter and nutrients, which are essential components of soil. The eroded soil escapes into water bodies in the form of sediments that affect the water quality and habitat of aquatic organisms. When natural vegetation is removed to promote agricultural systems, not only the nutrients stored in the vegetation are separated, but the organic matter and nutrients collected in the soil are also lost. From farming systems, nutrients are transferred through crop harvest. Thus, over a period of time, the soil unavoidably loses its fertility. Another damage to land resources is caused by landslide, which is downward movement of slope, forming materials comprising of natural rocks, soils, artificial fills, or mixture of these. Landslide is rapid mass movements involving either rapid flow or slip. Landslides, the main reason of natural disturbance, occur in areas having high rainfall, weak lithological structure and sharp gradients. Morphological situations, weathering, climate, lithology, hydrology and seismic factors are natural causes of landslides. Besides natural factors, anthropogenic factor also results in direct or indirect occurrence of landslides. The anthropogenic factors include rigorous cultivation, massive exploitation of forests, overgrazing, inappropriate drainage, and substandard road construction. Since landslide involves the movement of soil and vegetation, the self-sufficient soil plant system gets fragmented, which disturbs the community structure, nutrient cycling and soil strata. Generally, habitat destruction results in the loss of biodiversity and decrease in forest biomass and soil fertility. Numerous soil and crop management practices like conservation tillage, organic farming, crop rotation, contour plowing and strip cropping terraces can lessen erosion and reduce nutrient depletion of farming soils. Grasslands, another important component of land resources, provide forage and habitat to domestic animals and wildlife. 18% of the total land area in India is under grass cover, including fallow and wastelands. Degradation of grassland is largely due to overpopulation. To increase food production, grasslands are cultivated and changed to farming lands. In developing countries, grasslands are commonly overgrazed. Lack of plant cover because of overgrazing results in soil erosion. The change of grassland or forest to desert is called desertification, which can be minimized by shielding from grazing to allow the recovery of damaged vegetation, opting rotational grazing, removal of woody bushes or shrubs, which badly affect the productivity of grasses, and reducing loss of soil and water from the grassland. Wetlands are the land resources located in the low-lying areas generally covered with shallow water and have characteristic soils and water-tolerant vegetation. These may be either freshwater or coastal. Wetlands occupy nearly 6% of world's land surface and deliver vital ecological services. Wetlands are often drained or dredged for housing and industrial purposes. They are gradually susceptible to farming, pollution, and engineering constructions. Wetlands help in controlling floods by holding excess water and serve as groundwater recharging areas. Coastal wetlands are also destroyed for space and for developing coastal and farming lands. Conservation of wetlands usually employ the management approaches like preparation of wetland inventories, checking waste disposal in wetlands, and reduction of excessive inflow of nutrients and silt in the wetlands. The Constitution of India enables the central and state governments to enact laws for the preservation and conservation of land resources. Article 39, B and C of the Directive Principles of State Policy marks the duty of state and center to develop natural resources for common good. The 11th Schedule, Article 243G of the Constitution lists matters pertaining to the land improvement, implementation of land reforms, land consolidation, soil conservation, watershed development and management under authority and responsibilities of panchayat, local rural bodies. The 12th Schedule, 243W, lists urban planning and regulation of land use under the powers, authority and responsibilities of municipalities, urban local bodies. There are some policies and programs for the best possible use of land along with sustainable and integrated management of land resource such as Drought Area Development Program, 1972. Desert Development Program, 1977. National Waste Land Development Board, 1985. National Land Use and Conservation Board, 1983. The prime objective of these programs is the management of natural resources and maintenance of ecological balance. 1.4.2 Water resources. Ever since the advent of life on planet Earth, water is the source of life and is most indispensable for survival. Even the life is believed to have originated in the water itself. Presence of water on Earth was responsible for the origin of life. The sequence of Dashavatara, 10 incarnations of Lord Vishnu explain Darwin's theory of evolution. Water has both economic and intrinsic value. Economic value. The economic value of water includes benefits linked with income generation and health that provide water for irrigation, domestic and livestock, mitigation of poverty, employment generation and food security, return flows in hydrological systems, e.g. revitalization of groundwater, and value for water users, industrial, agricultural and domestic use. Intrinsic value. It includes the legacy and pure existence value. About 3/4 of Earth's surface is occupied by oceans, which contain about 97.5% of Earth's water in saline condition. Only 2.5% of water is freshwater. Most of the freshwater is frozen as polar or glacial ice, 1.97%. Remaining freshwater occurs as groundwater, 0.5%, and water in lakes and rivers, 0.02%, soil, 0.01%, and atmosphere, 0.0001%. Thus, only a small portion of freshwater is accessible for human consumption. Moreover, the distribution of freshwater is geographically uneven, changing significantly from nation to nation and even within a country from one region to another. Around 84% of total global evaporation occurs from ocean surface and 16% from land surface. At any given point of time, the amount of moisture in air is only enough to meet the total rainfall requirement of 10 days. Therefore, there is quick movement of water from ocean and land to the atmosphere. About 77% of the total rainfall on Earth is received on the sea surface and 23% on land. There is a net gain of 7% rainfall water on land, and the excess drains into the oceans by surface runoff through rivers and subsurface water flows. Thus, the hydrological cycle is absolutely balanced as the total annual evaporation balances with precipitation. Globally, about 70% of total water use is accounted by agriculture, and only 10% is used for domestic and municipal supplies, and the remaining is consumed by various industries. In India, accessibility of water has declined by 2/3. The water requirement of major water-consuming industries has increased 40 times. It was projected that water demand in agriculture sector will double by 2025. Thus, overexploitation of water resources without adequate revival has decreased the groundwater table. Further, leaching of pollutants from pesticide and fertilizer into aquifer has deteriorated the quality of groundwater. About 40% of world's population lives in arid or semi-arid regions. These people spend considerable amount of time, energy and effort in locating water for domestic and farming purpose. To meet the increasing needs of huge population, surface waters are overdrawn. On account of overuse of surface water, the adjacent wetlands may dry up. When groundwater is removed more than that can be recharged, the groundwater level decreases. Uneven irrigation in semi-arid and arid regions can cause accumulation of salt in soil, which affects the crop productivity. The non-stop depletion of groundwater along the coastal regions often leads to the movement of seawater into freshwater wells, spoiling the water quality. Thus, to conserve water, it is very important to reduce agricultural water wastage by increasing irrigation efficiency. By opting conventional Irrigation methods, plants absorb less than 50% water. Reducing water wastage in industry by recycling the used water, decreasing domestic water wastage, opting rainwater harvesting methods, afforestation and protection of watersheds are important water resource management methods. The acts and rules have been enacted for the management of water resources and prevention of water pollution. If anyone does not abide by the rules and regulations mandatory for preventing water pollution, she has to pay heavy fine in form of money or imprisonment or both. The earliest effort made for the management of water resources was the formulation of Easement Act of 1882, which permitted the rights to use private groundwater. It further stated that all surface water belongs to the state and is state's property. The Indian Fisheries Act of 1897 established two sets of penal offences whereby the government can sue the person who uses dynamic substances in any way with intention to catch or kill fish. The River Board Act of 1956 enabled the states to involve central government for setting up an advisory river board to resolve issues pertaining to water pollution. The Water Act of 1974 established an institutional structure for preventing and abating water pollution. Ganga and Yamuna Plan of 1985 and 2003 were formulated for protecting rivers from pollution. National Water Policy of 1987 was revised and adopted by the National Water Resources Council in April 2002. The National Water Policy defines water as a vital natural resource, a fundamental human need and one of most valuable national assets. The National Water Policy states that in view of vital role of water in human and animal life, for upholding the ecological balance, socio-economic and developmental activities, and considering the growing scarcity, the planning and management of water and its optimal, economical and equitable use has become a matter of utmost urgency. The policy further states that water is a part of larger ecological system. Realizing the importance and scarcity of fresh water, it has to be treated as an essential component for sustaining all forms of life. However, the success of national water policy depends on the maintenance of a national concurrence to its fundamental principles. National Water Policy, 2002, lays emphasis on water zoning, conservation of water, flood control, water sharing and distribution among states and role of science and technology in maintenance of water resources. In 2014, the Prime Minister of India launched Namami Gange project. It is an ambitious project of Indian government which integrates the efforts to clean and protect river Ganga in a comprehensive manner. 1.4.3 Forest resources. Forests are important renewable resources. They vary in structure and diversity and contribute considerably to the economic development of a nation. Plants, along with the trees, occupy large areas, yield a variety of products, provide food for living organisms, and are important to save environment. Depending on the climatic conditions and types of species present, forest can be classified as tropical, evergreen, partly evergreen, deciduous and dry forests. Forests also comprise of non-living constituents, for instance, water bodies, soil, rocks, etc. Around one-third of Earth's total land area is covered by forests, which are the storehouse of biodiversity and deliver vital ecological services to mankind. These services start with the following key roles of forests. Productive role, production of wood, fruits and a variety of products, for example, timber, resins, medicinal herbs, essential oils, latex, drugs, etc. Protective role, soil, O2, water, mineral elements and radiant energy. The regulative role improves atmospheric conditions and temperature, and enhances economic and ecological value of landscape. Forests efficiently control floods, drought, and global biogeochemical cycles, particularly of carbon. In India, in the beginning of 20th century about 30% of land was covered with forests, and it was projected that by the end of the 20th century the forest cover will reduce, and it has come down to 24.01%. This is substantially less than the optimum 33% forest area suggested by the National Forest Policy for the plains and at least 67% for the hills. Of the existing forests, less than two-thirds are dense forests, and rest are open degraded forest. The impact from human activities has affected the forest health, natural growth and regeneration. Many forest resources are vulnerable to overuse, destruction, degradation of environmental quality and switching over to other land uses. The main pressure results from anthropogenic activities, including expansion of agriculture, transport infrastructure, unsustainable forestry, pollution and forest fires. Forest cover has been decreasing, particularly in the developing nations. The main causes of deforestation are expansion of farming, urbanization, industrialization, excessive commercial use of timber, fuel wood, NTFPs and grazing. Forests, mainly in the mountains, provide substantial protection from floods. Deforestation has increased the soil erosion and reduced soil fertility. In drier areas, deforestation results in desertification. Deforestation has manifested in extinction of plant, animal and microbes. It also threatens indigenous communities whose livelihood, culture and survival depends on forests. Deforestation induces regional and global climate change. Because the precipitation drops in the deforested areas and droughts become common. Deforestation contributes to global warming by releasing stored carbon into atmosphere. Thus, large-scale deforestation has extensive penalties. For instance, fill circle decrease in the oxygen released by plants during photosynthesis. Fill circle habitat destruction of wild animals. Increase in carbon dioxide level, increases thermal level, which in turn results in melting of ice caps and glaciers with consequential flooding of coastal areas. Fill circle increase in pollution owing to burning of wood and decrease in carbon dioxide fixation by plants. Increased soil erosion as a consequence of decreasing vegetation cover. Fill circle loss of biodiversity and cultural diversity. Fill circle lowering of water table owing to more runoff and increased use of underground water intensifies the incidence of droughts. Fill circle reduction in accessibility of forest products, and fill circle shortage of fuel wood, weakening of economy, thus affecting the quality of life of people residing near forests. Excluding a few extremely inaccessible forestlands, all forests present on Earth have been impacted by human. People should be made aware of importance of forest and involved in forest conservation activities. The cutting of trees in the forests for timber should be discontinued. Grasslands should be restored and Forest Conservation Act should be strictly enacted to curb deforestation. In the recent years, various laws and regulations have been made for protecting the forest resources. If someone destroys or harms the forests, there is provision of fine or imprisonment or both. Initiatives for the management of forest resources are listed in Table 1. 1. Table 1.1 Initiatives for the management of forest resources. Year Initiative Salient Features 1927 Indian Forest Act enacted to consolidate the law related to forests and forests produce. 1952 National Forest Policy Awareness Program for Conservation of Forest Resources. 1972 Chipko Movement Saving Trees on Himalayan Slopes from Axes of Contractors. 1972 The Wildlife Protection Act Protection of birds and animals and or all matters that are connected to it, whether it be their habitat or the waterhole or the forests that sustain them. 1980 The Forest Conservation Act Protection and Conservation of Forests. 1981 The Forest Conservation Rules Protection and Conservation of Forests. Humans are undeniably a part of forests, and since ages, human has realized the benefits of forests in the form of spiritual values, medicines, shelter, food, materials, fuel, fodder, etc. Conservation of forest is a nationwide issue, hence, it should be undertaken with perfect synchronization between concerned government departments. 1.4.4 Mineral Resources. Minerals are naturally produced compounds having a clear structure and chemical composition. Minerals are non-renewable resources, vital for industrialized society and day-to-day activity. Mineral resources act as an important material base for socio-economic development. More than 95% of energy used, 80% of industrial raw material and 70% of Farming raw materials are derived from minerals. There are more than 3,000 known minerals. A few, like gold and diamond, are rare and valuable, while others, like quartz, are easily available. Because of increased industrialization, the consumption of minerals has also increased across the globe. The minerals, which are scarce today, will perhaps be consumed in next few decades. Even the minerals which are comparatively abundant, e.g. iron and aluminum, will become very expensive due to reduction of large, rich and easily accessible deposits of these metals. The minerals occur naturally in Earth's crust, but their distribution is not even. Minerals can be metallic, e.g. iron, copper, gold, etc., or non-metallic, e.g. sand, stone, salt, phosphates, etc. The use of minerals depends on its deposits. Some countries are rich in mineral deposits, while others lack. The use of minerals depends on its properties. For example, aluminum being light, strong and durable is used in aircraft, shipping, and car industries. Likewise, some of the important minerals along with their uses are: filled circle aluminum is the structural material used in packaging. Filled circle chromium is used for making chrome plate and steel alloys. Filled circle copper is used as alloy material in gold jewelry, silverware, brass and bronze. It is used for making electric wiring, pipes, cooking vessels, gold jewelry, alloys, etc. Filled circle iron is the main component of steel. Filled circle lead is used in the manufacturing of pipes, battery electrodes, pigments, etc. Filled circle manganese is used for making alloy steels, disinfectants. Filled circle nickel is used for making coins, alloys, metal plating. Filled circle platinum is used for making jewelry, equipment and as industrial catalyst. Filled circle potassium is used in the manufacturing of fertilizer, glass, photography, industry, etc. Filled circle silver is used for making jewelry, vessels, photography, alloys, etc. Filled circle tin is used for making cans, containers, alloys, etc. Filled circle uranium is used for making nuclear bomb, electricity, tinting glass, etc. Zinc is used for making brass, electrodes, medicinal purpose, etc. Non-metals like phosphorus is used for making medicine, fertilizer, detergent, etc. Sulfur is used for making insecticide, rubber types, medicine. Mercury is used for making thermometer, dental inlays, electric switches, etc. Extraction, processing and disposal of minerals have negative implications on environment. Mining not only interrupts and harms the land but also contaminates the soil, water and air. The land that has been damaged because of mining is known as derelict land, which can be reclaimed or reinstated to a semi-natural state by promoting revegetation to avoid further degradation and to make the land productive for other activities. Depending on the specific resource, method of extraction, processing, and use, exploitation of mineral resources can cause land disturbance, air and water pollution, erosion, and consumption of energy. Mineral conservation measures involve their recycling and reuse. In recycling, consumed or rejected items are gathered, remelted and reprocessed into new products. Some minerals, e.g. gold, lead, nickel, steel, copper, aluminum, silver, zinc, etc., present in various goods can be recycled. But the minerals like lead, zinc or chromium present in paints are lost during use. While reusing, used products are collected and again utilized. Recycling and reusing not only renews the mineral resources but also help in protecting the unspoiled land from mining, decreasing the amount of solid waste that must be discarded, and cutting down energy consumption and pollution. The replacement of abundant minerals for rare minerals can be useful. To ensure the prolonged supply of minerals for a longer period, consumers must reduce their mineral consumption. Sturdy and repairable products must be promoted instead of disposing them as waste. The total amount of usable mineral resources is merely 1% of all the minerals present in Earth's crust. But since the rate of consumption is high, therefore, these mineral resources are likely to exhaust rapidly. Some measures to conserve mineral resources can be: filled circle use of minerals in a planned and justifiable manner. Fill circle recycling and use of alternate renewable substitutes. Fill circle use of improved technology to use the substandard ores. 1.4.5 Food resources. Food is indispensable for the growth and development of living beings. Food provides essential materials called nutrients, which are obtained from plants and animals. There are thousands of edible plants and animals, out of which only a few constitute human food. The majority of food is obtained from cultivated plants and domesticated animals, although some food is obtained from forests, oceans and fresh water. Food crops. It has been evaluated that out of about 250,000 species of plants, about 3,000 have been tried as farming crops. Nearly 300 crops are cultivated under different agroclimatic conditions for food and approximately 100 are utilized on large scale. Some crops provide food, whereas others provide oils, fibers, etc. Raw crops are changed into valuable edible products by using diverse methods for value addition. Globally, only 20 species of crops are used as staple food. These include wheat, rice, maize, potatoes, barley, sweet potatoes, soybeans, oats, sorghum, millet, sugarcane, peanuts, beans, chickpeas, pigeon peas, bananas and coconuts. Livestock, domesticated animals act as important source of food. The main tamed animals used as food source by human beings are ruminants, which convert indigestible cellulose into digestible food products for human consumption. Milk is believed to be the complete food. Domestic animals like sheep, goat, poultry, etc. can be used for getting meat. Marine food resources. About 3/4 of Earth's surface is covered by oceans, which provide valuable food. Since time immemorial, marine algae have been used as human food. In many nations, animals are still fed fresh or processed seaweeds. Besides this, fishes, crustaceans and mammals are important among the animals found in water. Fish and seafood contribute about 17 million metric tons of high-quality protein across the globe. Currently, aquaculture offers only small amount of food, but its significance is increasing day by day. Food production systems. Broadly, there are two major types of agricultural systems: industrialized and traditional. Industrialized agriculture uses large quantity of water, fertilizer, pesticide and fossil fuel energy to produce crops. While the traditional agriculture, widely practiced in most of the developing nations, makes use of human labor with minimal or no input and produces food enough for the farming communities. Traditional agriculture involves high input of human labor, fertilizer and water to considerably increase the crop yield. Despite increased food production, the increasing human population is exceeding the food supply, particularly in the developing nations. Food scarcity has caused malnutrition and hunger in underdeveloped countries. Both industrialized and traditional agriculture considerably affect air, soil and water in numerous ways. For instance, loss of biodiversity due to habitat loss, substitution of wild varieties of crop plants with lesser yielding varieties, which results in loss of genetic diversity. At the same time, the inadequate precautions in farming result in soil erosion and decreased soil fertility, and in extreme cases even waterlogging. Salinization and desertification. Excessive use of farm machinery increases air pollution and greenhouse gas emission. Heavy use of pesticide in industrialized agriculture causes air, water and soil pollution. Excessive use of pesticide kills fishes and pollute drinking water. Likewise, considerable portion of heavy fertilizer inputs may escape to water bodies, causing water pollution. This in turn affects the food chain and threatens the life itself. Hence, to secure the continuous supply of food, it is important to switch over to sustainable farming practices. 1.4.6 Energy resources. Generally, energy resources can be categorized as renewable or non-renewable. Non-renewable energy sources include fossil fuels and nuclear energy. Fossil fuels include petroleum products, natural gas and coal. Nuclear energy is mainly obtained from the nuclear fission of uranium. The global reserves of fossil fuels and uranium are limited and will eventually be drained. Burning of fossil fuels for getting energy has negative ecological consequences such as global warming, air pollution, acid rain and oil spills. It is essential to reduce the use of non-renewable energy resources and substitute them with renewable resources. Renewable energy resources are regenerated by natural processes so that they can be used forever. Renewable energy usually causes lesser negative ecological impact than the fossil fuels or nuclear energy. With the current status of technology, the generation of renewable energy is often higher than energy produced by fossil fuels or nuclear energy, but, with technological advancement, the cost of renewable energy is expected to decrease. Among the renewable energy sources, the most important one is the solar energy. The other renewable energy resources are hydropower, wind, geothermal energy, ocean waves and tidal energy. Solar energy. Solar energy is the radiant energy that can be used directly or indirectly for human welfare. It can be used for direct heating, and on the other hand, the heat can be converted into electricity. Photovoltaic cells convert direct solar energy into electricity. Biomass energy. It is obtained from the materials such as plant material and dried residues, freshwater and marine algae, agricultural and forest residues. Biomass includes biodegradable organic wastes from industries like sugar mills, breweries, etc. About half of the world's population depend on biomass as their main source of energy. Fuel wood is still a major source of energy for domestic purposes. Biomass fuel can be a solid, liquid or gas, which is burned to release energy. Solid biomass includes wood, charcoal, animal dung and peat. Biomass can be converted into fuels, also known as biofuels, such as biomethanol, bioethanol, biogas, biodiesel, etc. Biomass, mainly the animal waste, can easily be transformed into biogas in biodigesters by using the process of microbial decomposition. Biofuels are cleaner fuel, whose combustion produces fewer pollutants than other combustible energy resources. It is a mixture of gases that can be stored and transported easily. Among other renewable energy sources, the following are important, but their accessibility varies from one region to another. Geothermal energy, heated groundwater ascending as hot water or steam, or as hot springs, can be used to turn turbines and produce electricity. Hydropower, it is the energy produced by water falling from a height, which rotates the turbines at the bottom of dams to produce electricity. Hydropower generates nearly 1/4 of world's electricity and is generally cost-effective than electricity produced by thermal power plants. Ocean wave energy. Ocean waves produced by winds have the possibility to rotate a turbine and produce electricity. Tidal energy, the difference in the water level between high and low tide, known as tidal energy, is used to generate electricity. Wind energy, rotation of fans by the action of wind can be used for generating electricity. However, reaping wind energy is possible only in the areas that get moderately constant winds, for instance islands, coastal areas, and mountain passes. 1.5 Availability and distribution of natural resources. Resource distribution is the allocation of resources, including land, water, minerals, etc., at different geographic locations. It also refers to the geographic availability of resources on Earth. A particular place may be rich in one resource and may be lacking other. Consequently, resources are scattered unevenly across the globe. Different regions have access to different renewable or non-renewable natural resources such as freshwater, fossil fuels, fertile soil, or forest-based resources, which is governed by their geographic location and geologic processes. Availability or absence of a resource regulates the socio-economic development, political relationships, and culture. The availability and distribution of natural resources also depends on physical factors like land, climate, and altitude. The distribution of resource is irregular as these factors differ from one place to another. Land is an important resource because it provides habitation and support a variety of flora and fauna. The land utilization pattern in turn is controlled by topography, soil, climate, minerals, and availability of water. Human factors, for instance, population and technology, are also important determinants of land use pattern. In terms of area, India ranks 7th in the world with a total area of 32,87.263 square kilometers, which accounts for 2.42% of total area of the world. Out of a total land area, about 170.0 million hectares is under cultivation. India's forest cover is 78.92 million hectare, which is 24.01% of the total geographical area. Iron is the backbone of modern civilization and 4 varieties of iron ore are generally found. India has high-quality iron ore in plenty. Magnetite is the best quality iron ore. It is found in Andhra Pradesh, Jharkhand, Goa, Kerala, Tamil Nadu and Karnataka. Hematite is found in Andhra Pradesh, Jharkhand, Orissa, Chhattisgarh, Goa, Karnataka, Maharashtra and Rajasthan. Limonite is found in Raniganj coal field, Garhwal in Uttarakhand, Mirzapur in Uttar Pradesh and Kangara Valley of Himachal Pradesh. Siderite has just 40 to 50% pure iron. India has 5th largest coal reserves in the world. The energy obtained from coal is about twice that of the energy derived from oil. Coal deposits are mainly found in eastern and south-central India. Jharkhand, Orissa, Chhattisgarh, West Bengal, Madhya Pradesh, Telangana and Maharashtra account for 99.08% of the total known coal reserves in India. Bauxite is one of the main metals like aluminum. The major bauxite producing states in India are Orissa, Jharkhand, Gujarat, Maharashtra, Madhya Pradesh, Karnataka, Tamil Nadu, Uttar Pradesh and Goa. India had about 750 million metric tons of proven oil reserves, which is the second largest amount in the Asia-Pacific region. Most of India's crude oil reserves are located in the western coast and in the northeastern parts of the country, though substantial undeveloped reserves are also located in Bay of Bengal and Rajasthan. Likewise, India has natural gas reserves, which primarily consist of methane, propane, butane, pentane and hexane are also present. Assam, Gulf of Khambhat, Kadalo district of Tamil Nadu, Barmer, in Rajasthan, etc., are natural gas reserves of India. The development of wind energy started in India in 1990s and has considerably increased in the last few years. Domestic policy for development of wind power has placed India at 4th rank with largest installed wind power capacity in the world. Wind power accounts for 14% of India's total installed power capacity. Solar power, being abundant, offers a solution to curb emissions and global climate change. India has high solar insolation, which provide an ideal combination for solar power. In solar energy sector, some large projects have been initiated in the recent years. Land is one of the natural resources on which the entire superstructure is shaped. Even if the land resources are never inexhaustible, on a per capita basis they will decline considerably. Thus, land use is an amalgamation of physical, chemical, and biological systems besides human, societal progressions and behavior. The population is rapidly increasing and there is pressure on arable land resources to meet the food and energy requirements. Land use includes the management and adjustment of natural environment with built environment, for instance, settlements and semi-natural habitats. Land use is the total of provisions, activities, and input that people undertake in a specific land cover. Land is an inadequate resource, whose supply is fixed for all purposes. At the same time, the demand of land for various purposes is substantially increasing with the increase in human population, industrialization and economic growth. The land is used for agriculture and non-agriculture usage. Agricultural land is the land appropriate for agricultural production, both crops and livestock. It includes the net sown area, current fallows and land under miscellaneous trees, crops and groves. In India, agricultural land aggregates to approximately 46% of the total geographical area of the country. Non-agricultural land includes the land under forests and permanent pastures, land under other non-agricultural uses and land categorized as cultivable waste besides barren and uncultivated land of mountains and deserts. 1.6. Interrelationship among different natural resources. There exists an interrelationship among different natural resources, which are important for the sustenance of life on Earth. For instance, land-water relationship is one of the processes in which the land supports water on Earth's surface, and in turn it affects the climate by regulating the unequal distribution of water and land surface. The water bodies play an important role in controlling the temperature, as these help in cooling the land during the summers. There is no resource which is more important for human, plants and animals than water. All living beings require water to flourish. In short, water resources make the world go round. Water is the most important resource, which supports life, while forests' resources support water. Thus, the relationship between water and forests is vital. Forests are directly accountable for gathering and filtering rainwater, which is essential for evolving clean water sources for plants, animals, and human beings. This is known as sponge effect, in which rain falls and trees in the forest absorb rainwater, filter the pollutants and gradually release it back to the adjacent water bodies. This interrelationship safeguards various ecosystems in the forests. Forest water is comparatively purer than other water sources, which reduces water treatment costs and makes it simple and profitable to get clean water back into the ecosystem. Along with growing accessibility of clean water through filtering rainwater, forests also protect the ecosystems adjacent to the water bodies. When a forest is close to a water body, it has a positive effect on water. For instance, the shade of trees keeps the water at a specific temperature, sustaining the species living in water and preserve water quality. However, reckless deforestation is putting access to clean water and the ecosystems within the forests are at risk. Thus, it's essential to protect forests. Likewise, the interrelationship between land use and groundwater has long been acknowledged, but has not been extensively translated into policies and practices. Groundwater is an important resource for potable water supply, irrigated agriculture, and industry, in addition to its natural ecological function of supporting river flows and aquatic ecosystems. But changes in the land use impact groundwater. The understanding of groundwater land and land groundwater interface is desirable to help cross-sector discussion on evolving management approaches aimed at sustaining water resources and increasing land productivity. Land use management activities yield substantial groundwater quality and quantity benefits at comparatively moderate price. Most groundwater accumulates directly from surplus rainfall infiltrating the land surface. Thus, land use has a major impact on both groundwater quality and recharging rates. Different land use practices leave distinct impacts on the quality of groundwater. Revival. Land use practices influence groundwater recharge rates, mainly under arid conditions. Similarly, forests and wetlands accounts for 75% of world's fresh water. The quantity of water these forests deliver downstream varies with climate, geography, soil, forest structure, and forest management practices. Among all kinds of land use modifications, irrigated agriculture using a surface water source has the highest impact on groundwater, both increasing the recharge and changing water quality as the excess irrigation water permeates into shallow aquifers. Increasing irrigated vegetable and fruit cultivation can have the contrary after effect, which can evidently decrease the recharge rates and possibly reduce the escape of agrochemicals. Thus, forest resources are vital for maintaining an appropriate water cycle. In forests, water gets collected in soil, filtered, used by the vegetation to produce biomass, and evaporated when the leaf transpires. In atmosphere, this moisture becomes available for condensation and precipitation. Land use and water resources are inseparably intertwined. The need to protect the quantity and quality of water resources can impact the potential land uses and land management practices, while water accessibility is a prerequisite for land use demanding irrigation. Land use and land management changes impact water resources, for instance, variations in catchment yields, infiltration rates, dissolved organic carbon and nutrient relocations. Thus, it is evident that all types of natural resources are interrelated and are indispensable. 1.7 Let us sum up. A resource, which occurs in nature, is called a natural resource and is not manufactured by human The survival of human and other living organisms depends on these resources. These resources can either be renewable or non-renewable. With the developmental activities, humans has ruthlessly harnessed the resources, which has posed threats to survival of human civilization itself. Natural resources vary greatly with location, climate, soil, quantity and quality. For instance, a specific forest type may occur only in some nations. Amongst the Earth's natural resources, the following contribute considerably to human welfare. I. Land. E. Water. E. Forests. IV. Minerals. V. Food and V. Energy. Land is one of the most important resources, which helps in sustaining life. It is used for agriculture, construction of houses, roads and railway tracks, establishing industries, grazing animal, mining activities, etc. Land consists of soil, which is a combination of organic and inorganic matter. 1/4 area of Earth is the land, which is mainly covered with farming landscapes, natural forests, grasslands, wetlands, and man-made urban and rural settlements. Human activities like deforestation accelerate soil erosion and results in loss of soil fertility by transportation of organic matter and nutrients, which are essential components of soil. There are some policies and programs for the best possible use of land along with sustainable and integrated management of land resource. Water is the source of life and is most indispensable for survival. Water has both economic and intrinsic value. Only a small portion of fresh water is accessible for human consumption. The National Water Policy defines water as a vital natural resource, a fundamental human need and one of most valuable national assets. National Water Policy, 2002, lays emphasis on water zoning, conservation of water, flood control, water sharing and distribution among states and role of science and technology in maintenance of water resources. Forests are important renewable resources. The forests have three main roles, viz. Productive role, protective role and regulative role. Forests efficiently control floods, drought, and global biogeochemical cycles, particularly of carbon. Excluding a few extremely inaccessible forestlands, all forests present on Earth have been impacted by human conservation of forest is a nationwide issue. Hence, it should be undertaken with perfect synchronization between concerned government departments. Minerals are naturally produced compounds having a clear structure and chemical composition. Minerals are non-renewable resources, vital for industrialized society and day-to-day activity. Mineral resources act as an important material base for socio-economic development. Extraction, processing and disposal of minerals have negative implications on environment. Mining not only interrupts and harms the land but also contaminates the soil, water and air. Mineral conservation measures involve their recycling and reuse. Food is indispensable for the growth and development of living beings. Food provides essential materials called nutrients, which are obtained from plants and animals. The majority of food is obtained from cultivated plants and domesticated animals, although some food is obtained from forests, oceans and fresh water. Generally, energy resources can be categorized as renewable or non-renewable. Non-renewable energy sources include fossil fuels and nuclear energy. Renewable energy resources are regenerated by natural processes so that they can be used forever. Renewable energy usually causes lesser negative ecological impact than the fossil fuels or nuclear energy. The other renewable energy resources are hydropower, wind, geothermal energy, ocean waves and tidal energy. Resource distribution is the allocation of resources, including land, water, minerals, etc., at different geographic locations. The availability and distribution of natural resources also depends on physical factors like land, climate and altitude. There exists an interrelationship among different natural resources, which are important for the sustenance of life on Earth. Thank you for watching. We will see you in the next video, with next chapter.